Particles in solids are arranged in a regular order. One possible arrangement involves the particles arranged in vertical and horizontal rows. We call this regular arrangement a crystal lattice. The particles are held together by chemical bonds. These bonds are strong and hold the particles in fixed positions within the solid. It is this that gives solids their regular three-dimensional shape. The particles are packed very closely together with little space between them. This makes solids dense. Strong bonds give solids their hardness and strength. With the particles so close together, solids are hard to compress. The particles in a solid have energy and vibrate randomly about their fixed positions. This allows solids to keep their regular shape. As the temperature is increased, the particles vibrate more vigorously and the material expands. Note that the particles themselves do not become bigger. It is the spacing between the particles that increases. The particles in a liquid have more energy. Some of the bonds between the particles are broken. This allows liquid particles to move past one another. The particles are now arranged in an irregular manner, which is continually changing. A liquid can flow as the particles slide past one another to take the shape of the container. The liquid particles are still very close together, giving liquids high densities and making them hard to compress. Particles in gases have the most energy. The bonds between the particles have broken, allowing them to move in a completely random manner. The gas particles are very far apart. Most of the volume occupied by the gas is empty space. Gases have very low densities. Gases can be easily compressed. The particles of a gas move rapidly. Gases will expand or diffuse to occupy the total volume of their container. When the particles collide with the walls of their container, they exert a pressure. If the temperature is increased, the gas particles move more quickly and collide with the walls more often. This increases the pressure. Expansion. As we have seen earlier, solids expand when they are heated. As the solid expands, it can exert a tremendous force on its surroundings. Concrete roads and railway lines are built with gaps between sections to allow for expansion in hot weather. Solids expand the least because their particles are the most strongly bonded. Liquids expand more than solids. We use liquids in thermometers to measure temperature. Gases expand the most of all states. This is because the particles are the least strongly bonded. The rapid expansion of hot air gives the balloon sufficient uplift to rise. When cooled, solids, liquids and gases become smaller or contract. When the air in the balloon cools, the balloon contracts and loses buoyancy. Changes of state. Energy changes. The three states of matter can be interchanged by heating or cooling. Heating supplies energy, enabling bonds to break. Cooling removes energy, enabling bonds to form. Each change of state is given a particular name. Melting occurs when a solid changes to a liquid. Boiling or evaporation occurs when a liquid changes to a gas. Condensation occurs when a gas changes to a liquid. Freezing or solidifying occurs when a liquid changes to a solid. A few materials change directly from solid to gas or from gas to solid. This process is called sublimation. Solid carbon dioxide will sublime. If solid carbon dioxide is placed in a tied balloon, the balloon will self-inflate.